Physicists discover an exotic material made of bosons. Take a lattice, a flat section of a grid of uniform cells like a window screen or a honeycomb, and lay another similar lattice above it. But instead of trying to line up the edges or the cell of both lattices, gives the top grid a twist so that you can see portion of the lower one through it. This new third pattern is a moire, and it's between this type of overlapping arrangement of lattices of tungsten diselenide and tungsten disulfide where UC Santa Barbara physicists found some interesting material behaviors. We discovered a new state of matter, a bosonic correlated insulator, said Richard Exine, a graduate student researcher in the group of UCSB condensed matter physicist Chenao Jin and the lead author of a paper that appears in the journal Science. According to Exine, Jin and collaborators from UCSB, Arizona State University, and the National Institute for Material Science in Japan, this is the first time such a material, a highly ordered crystal of bosonic particles called excitons, has been created in a real as opposed to synthetic matter system. Conventionally, people have spent most of their efforts to understand what happened when you put many fermions together. Jin said, the main thrust of our work is that we basically made a new material out of interacting bosons. Bosonic correlated insulator. Subatomic particles come in one of two broad types, fermions and bosons. One of the biggest distinctions is in their behavior, Jin said. Bosons can occupy the same energy level. Fermions don't like to stay together, he said. Together, these behavior construct the universe as we know it. Fermions, such as electrons, underlie the matter with which we are most familiar, as they are stable and interact through the electrostatic force. Meanwhile, bosons, such as photons, particles of light, tend to be more difficult to create or manipulate, as they are either fleeting or do not interact with each other. A clue to their distinct behavior is in their different quantum mechanical characteristics, Exine explained. Fermions have integer spins such as half or fermions have half integer spins such as 1 by 2 or 3 by 2, etc., while bosons have whole integer spins 1, 2, etc. And excitons is a state in which a negatively charged electron, a fermion, is bound to its positively charged opposite whole, another fermion, with the two half integer spins together becoming a whole integer, creating a bosonic particle. To create and identify excitons in their system, the researchers layered the two lattices and shone strong lights on them in a method they call pump probe spectroscopy. The combination of particles from each of the lattices, electrons from the tungsten disulfide, and the holes from the tungsten diselened, and the light created a favorable environment for the formation of and interaction between the excitations while allowing the researchers to probe these particle behaviors.